Punnett problems, monohybrid crosses. When we're looking at monohybrid crosses, we look at that prefix mono, which means that we're looking at just one particular trait. You will learn about dihybrid crosses, and if your teacher's evil, sometimes trihybrid crosses, but most of the time we just stick with mono and di. So again, mono, we're just looking at one trait. So in question 1 here, the P generation of pea plants. Now the P generation actually has nothing to do with peas itself. When we're talking about P, we're talking about the parent generation. So the first 2 plants that we're starting with when we do our experiments. The P generation of pea plants consists of big T tall plants and little t short plants. Tall is dominant over short, across a tall plant and a short plant. I want to point out a couple things right here. When you have big T, we call this plant homozygous dominant, because we have big with it. So homo means same, and dominant means the dominant trait, in which we write in the capital letter. So big T is homozygous dominant. Little t is also homozygous, but since we're looking at the little and the recessive trait, we call this homozygous recessive. So you'll hear those terms thrown out now and then, and I want to make sure you know what they are. So homozygous dominant is big, homozygous recessive would be little. So in this particular one, we're going to cross a tall plant and a short plant. And they told us here that the tall is big T. Sometimes we have to wonder, is it big little? But they pointed it out in this example. So we have big T crossed with little t. When we fill out our Punnett Square, we are going to separate out the alleles that could be inherited. So our offspring from the father have a 50-50 chance of getting big T, or in this case, big T, so it's really ended up being a 100% chance. Our mother is donating the little t. And so when we cross these out, this first, we have a probability of getting big little, and big little. Now when we draw the Punnett Square, we draw it with 4 squares because we have a 50-50 up here and a 50-50 down here. It doesn't mean that our breeding is going to result in 4 babies necessarily. That's a real common misconception. It's just looking at what's the probability and the odds. In this particular one, our genotype ratio, the only thing that our offspring can inherit is big T, little t. All 4 odds essentially have that. So our ratio is, there really is no ratio. It's 1. If you want to make it ratio, you could say 1:0 for inheriting the big T, little t. The phenotypic ratio, again, would also be just 1 or 1:0. And I like to put what phenotype they'd be inheriting. Anytime you have this, which is known as the heterozygous, so I'll just put a little note over here. Heterozygous, it's the big tall. Sometimes we also refer to this as the hybrid. That the only option there would for it to be tall. So when we see inheritance, that's what we consider Mendelian inheritance. We would always see the dominant trait when we have our offspring being heterozygous genetically. In question 2, it says cross the 2 F1 generation plants. Well, F1 is referring to phylele. So the F is equal to phylele. It's a term that I think Mendel actually came up with, but it just means that next generation that we're getting. And so the F2 generation plants means that we take 2 plants from this previous mating, and so technically you are inbreeding, but we would cross those 2, so 2 heterozygous plants. Now when we fill out our Punnett Square, first we just look at the first parent. Usually it's the father because we're sexist, and we look at which particular traits could he donate to his offspring. Well, he could donate the big T, or he could donate the little t. And remember, those would get passed on through meiosis. If we look at the mother, she also has the dominant trait and the recessive trait. So on her Punnett Square, we could do the dominant and the recessive. Now, could you write it recessive dominant? Yes, you can. We just typically do the capital letter first. I think it's kind of like an English language thing. So here, our first crossing, this could be big T, here we could have big little, down here would be big little, and in our last corner is little little. So our genotype ratios here, sometimes I like to write out the traits that we're looking at. So we have the big T with the big little and the little little. Our number of squares with big T is 1. The number of squares with big little is 2. And the number of squares with little little is also 1. When we look at our phenotype, the trait that's actually expressed, our big T and our big little would both be expressing the tall trait, and the little t would be expressing the short trait. So if we come back over here and look at our offspring, this one, and this one are all exhibiting tall. So there are 3 with tall and 1 with small. Again, this doesn't mean that we're going to be having 4 offspring and that we're guaranteed 3 tall plants and 1 short plant. It just means, statistically speaking, if you were to mate these two together, odds are you would end up with a 3-to-1 ratio. Now that means you could have 4 offspring, 3 being tall, 1 being short. You could have 2 tall, 2 short. You could have 1 tall and 3 short. It's statistics. It's randomness. It's what happens. It also means that you could have 100 offspring and have 75 of those tall and 25 short, or you could have 50-50. But odds are you'd probably hit close to that 3-to-1. And if you go back and look at Gregor Mendel's work, he actually statistically was really close to hitting his predicted odds right here. So in down here we have the F1 generation. This is what we call the F2 generation. It's another phyleal generation. Just means we're continuing to mate the generations. And so we're crossing 2 short plants. Now when we cross 2 short plants, that means that we know, genetically speaking, they are going to be little t and little t. And I'll let you go ahead and fill out that square because that one's pretty easy. When you come down to number 4, it's asking you to cross 2 homozygous tall plants. Well, homozygous tall plants, I'd actually probably refer to those as homozygous dominant plants, but homo means same, so that means genetically speaking they have the same genotype on either side. So crossing big with big little, and you should be able to figure out your genotype and phenotype ratios from there. Let me know if you have any questions.